in this one, I need to. Okay. So this is good to go. Good. I always look super lost. Yes, this is live, Daniel. Getting there. Hello, Kuroshili Z91. Hope you're doing good. Today, again, we're on the Google Meet because we're gonna have an interview later on in the at 11, I think, in 30 minutes with Joseph Suarez. It's the maintainer of PufferLib and the guy that made a Neural MMO. So we're gonna talk to him. I have a whole bunch of questions. I'm gonna first show you a whole bunch of stuff before, just to kind of get you in the mood of like what the heck this thing even is. And after that, we'll be able to have a little chat with the man. Yeah, a really cool library, by the way. Like pretty nice. There's also like a lot of cool environment. It's optimized like crazy, and it's rare to see somebody that like his stuff that much, right? So the guy really like this shit. So, he's maintaining this like crazy, and he's thinking about it. If you follow him on Twitter, I have a whole bunch of links in the description. Yeah, you're gonna see he's like almost live every day, and then the guy is like deadlifting for a few, and then like optimizing his library like crazy. So a cool thing really that he built. Yeah, so that's it. Don't forget the format, right? So like this is really a space for you to ask like a whole bunch of questions. Don't hesitate at the beginning if you're new to deep learning, RL, whatever. Don't hesitate to ask like beginner question, like when you just it's between like you and me, and when the actual guy will come in, right? Then you can switch to asking him a question. So there's a whole lot that you can ask him about. He has a very interesting background. I'm gonna go over it a bit. But yeah, that's the whole point of this. And I hope that you all are having a great start of the day. So let's get started. I made a whole like Tildraw kind of board for you guys. Actually, yeah, I'll just show you. Like, if you wanna just like float around and then like check it out, you can go over there directly, and you'll be able to kind of view the stuff without me having to show you. So we're gonna go through all of this, but you see it's not that complicated. It's a cool library, right? It's not like a very complex library in the sense of like it can do like a billion thing. It do like a few things really well. So yeah. So Joseph Suarez will be the guy that we're gonna chat with. Is a PhD from MIT, and he was working on Neural MMO in his during his PhD. So an earlier version of it, and now there's like a newer version, V3, which is like surprisingly pretty intense. They've done a few competition about this, right? Which like had a lot of submissions. So you might, if you were there in the field in 2022 and stuff, you might have seen this, but it's pretty cool. And the guy has intense background. Like I did a whole interview with him that I'm gonna edit out and like publish. But like he was at Feifei Lab, like when he was something like 16 years old, in high school stuff. It was like next to Karpati and whatever it is. No, the guy like is a hardcore researcher. So this Neural MMO has a multiple iteration, right? It's also the subject of one of his dissertations. So like you can check out the video over here on his YouTube channel. This whole thesis defense is there, which is crazy. Like, I don't know a lot of people that like literally push their whole thesis defense on YouTube, but the guy is really solid, and it's a really good one. So Neural MMO, it's like a very multi-agent, highly optimized, complex environment, right? So he was really into this type of stuff, more than like just a simple game one agent type of environment. He wanted to make like something that is a bit more complex, so that we can push the limit of the algorithm versus just looking at the algorithm and trying to theoretically improve them. So he was all about that, and you realize that with like just the PPO type of algorithm and the architecture that we already had, you can go very far. So this is this stuff. Actually, I think let's actually see it live right here. So you can go to PufferLib, and the thing is like this stuff is so optimized that it's literally running, right? Like this thing is running on your web browser. Like the environment is running there, which is a nice feat. So you have the Neural MMO stuff here. We can take a look at it a bit. It's gonna load the whole thing, and it's a simulation with a whole bunch of stuff. Like there's like an economy in there. It's really like a mini RuneScape, right? And that's kind of the the inspiration that he had for it. So you have this agent that has like 0 level and is like trying a bunch of stuff out, right? It's like exploring and stuff like that. And then you see this one is level 1. He's trying to kill it, but you're able to kill this one. He's gonna take, I don't know, maybe he's gonna take the shovel. Yeah, it took the shovel over there. I don't know what he's gonna do with it. But yeah, this is running, and then like there's other agents in there that are doing their own stuff, right? So pretty cool. Yeah, actually, can I play this? I think I can. Wait a second. Wait a second. Left control to toggle, no shift, like the, okay, can I just, okay, I think I can play this directly if I want to, which is funny. So like you can let the agent play, you can like take control and test a bunch of stuff. But the whole point of this is that you can create like a very complex environment, and then push the limit of RL. That's the rough idea. What's going on here? So that's that. Wait a second. I will need to stay in a call, please. I don't want to get booted out. Yeah. So this is the rough idea of Neural MMO, and this environment is made possible specifically because of PufferLib. It's like his library that he built out earlier on in his PhD, and then like he kind of kept improving it. And this thing is absolutely cracked. Like it can go very, very fast. And there's a lot of to understand about like the environment ecosystem for RL. But like he was so deep in it that he figured like what could be improved with it, and he actually did that. He spent his time, improved it, and now like you have a library that is very clean and that can like provide speed up like crazy from the beginning. So in this paper it shows that like there's like 12 environment, now there's 24 of them, so there's much more. Like if you look at the ocean one, like you have all of these environments that were built out, right? And then you can just like put your agent in there and then train them, and then like study what's going on. You can also make your own environment and use like this stuff, the PufferLib, as a wrapper to make it faster and more optimized. There's these other environments that are getting created, and you can also contribute to that if you're interested into that sort of stuff. The main contribution here is that it's like a one-line wrapper, right? You don't have to do crazy stuff. So if you're using Gymnasium and Petting Zoo, right, which are like comment environment that like you can like do research on, you can just like wrap them up and then you're good to go. And they have all sorts of things they're doing for speed up. So you have vectorization, you have emulation, and like they can get like some pretty crazy speed up on some of them. And also those that are in the ocean kind of section of his library, they're written in C, so they're very optimized, right? It's much more optimized than what you can have. Either way, he tried in C++, he's tried in Rust. Like he tried for you all of the different combination of stuff. And you have like a simple algorithm, PP1. It's a modded one, right? But you can directly just use library and then like start to have fun with it, and start to actually learn about RL also in this way. So yeah, right now at the time there was 25 environment, and then they did a big experiment on Neural MMO 3.0, and they ran 640 billion steps in 3 days and 8 hours on like 6 GPUs. So petabyte of observation, because like this thing is crazy. Like if you think about it, like as it's going, it's still going, right? Like the guy, look, now he has like a bow or whatever it is, and it's like he has an armor set and all this shit. Like the amount of complexity that is running here is pretty high, but yet it's optimized enough that like it can just go and run. So cool stuff. We have a question here. I had a question for you that I will appreciate an answer to. Is this book good for learning mathematics for machine learning? Yes, it's a good one. I think I have it somewhere. Where is it? Did I have it? Oh no, it's in my desk. It's over here. Yeah, it's a good book. Get it, right? It's a good book. Yeah, very, very useful. Where was I? I was in the partial differentiation and gradient section. I like this book because it's like everything condensed in this. There's like the essential of linear algebra and like whatever you need for machine learning, and it doesn't try to cover everything like in super depth. It's trying to go for breadth and then explain to you like the minimal amount you need, and it points you to other resources. Some of them are like YouTube, some of them are like other books or papers and stuff like that. And the cool thing with this book is that like in each section that you have like exercise, right? So you have like these exercises that you can actually do. The only drawback is that they don't provide a solution. Like what the fuck? But you can, they're online, right? You can find them. The book is also free. You don't have to buy it, right? You can just go on GitHub and like get it. But I recommend it. It's a good one. It's well made. Okay, folks, buckle up. We're gonna go. Before that, I just want to thank everybody, right, that contribute to this channel. Super useful. I still see you guys. You're still subscribing in the paid membership type of stuff. So for those that don't know, like the paid stuff, you don't have to do it, right? Like it's fine if you don't. It's just that like after some time I take the live stream and then I'm gonna put them into like this kind of member section. Yeah, but like it's really nice of you to support the channel and like donate here. So thank you all of you guys. Every time I see a new one, I'm like, that's it. Thank you very much. So the paper we're going to look at is this one, right? So it's the PufferLib 2.0. Just this, right? Absolutely crazy that like he managed to publish a paper on a library. So for those that don't know, like in general, like journal don't accept like engineering type stuff in research publication. And on top of that, it's where it's like it's a reinforcement learning journal that he got accepted in, which is absolutely crazy. And then I think he also submitted into a conference. Now they're getting more it's being more acceptable, but generally they don't accept any of this, and they just look at theory and like these kinds of results. So yeah, it's just like it shows how cracked this library is. So you can check out the paper in depth, but we're gonna go over it. So the background here is that like RL research is usually slow, right? It's slow, cumbersome. Like it's everything is run on CPU for like a specific reason, because it's difficult to kind of just emulate like to formulate it completely into a GPU. So it run in few thousand steps per second on a modern CPU. There are some part that need to go into GPU, like for example, like the model training and stuff. But because like nothing is optimized on the CPU side and the environment side, it means that like modern GPU are like at 5 to 20% utilization, which is massively wasteful if we have access to like these GPUs and like these CPUs that are a bit more beefed up. So this is limiting the RL research. It didn't like that, and it was seeing that back in the day in this stuff. And there is some library that exists. We're gonna go to them, but like they all have some kind of limitations. So for example, Gymnasium, they don't have multi-agent support. Pitting Zoo, like they don't provide native multi-processing support. So if you have multiple core, it's just kind of a mess. Yeah, and like most environment are written Python, which like not necessarily super fast to begin with. So there's ways to optimize this whole thing so that we can just go faster and test more stuff. And like one of the main thing that you have to understand is that with RL, RL is very sensitive to the parameter that you're using, right? So it can, like, you have to do extensive parameter sweep and stuff like that. So parallelization at the core is absolutely important. So if you don't have it and you don't know how to set it up, and then you're doing it a bit more natively, you're gonna spend a lot of time just like doing nothing, right? So actually you're gonna play RuneScape on the side while your model is running. Oh wait, we have a question. Oh, Adam says happy birthday. Thank you, man. Thank you. Hi Mark. We're going right now, and we have to get that done in like 15 minutes. So we're gonna speed up. So there's a whole bunch of like a library, right? Gym was the one from OpenAI, but then like they kind of ditched the whole RL effort, and now like Gymnasium took it. It's like a foundation, Farama, I think, something like that. But the Gym library is not maintained. But the way they codified the API is still being used heavily. So Gymnasium is that, and it's used for research, right? And then you have Petting Zoo over here, which is kind of the same, I think, as Gymnasium, and I think it's same also foundation that is like getting these two. But this one is for multi-agent thing, right? Yeah. So that's the setup that you have, and then you have the DM environment, which is the version of DeepMind for RL, right? Like usually people don't use that; they use Gymnasium or Petting Zoo. So you have like these two that are like the most used, and then you have everything else here. You have Clean RL, so it's one file implementation of like a bunch of things that you need for RL. You have Stable Baseline 3 for like a whole bunch of algorithm. You have Sample Factory, Tinchu, Torch RL. So you have a whole bunch of these things. That's the idea. And like PufferLib, it currently just focused on the CPU environment. They're not trying to replace, let's say, the GPU thing for like the motor control for robotic and all this. I think like we have a question on this for him, if like he's going to support it in the future. But he's heavily focused on like the CPU because this is where like he thinks that there is the massive bottleneck. And also it's because like we can't expect people to write environment in GPU. It's a bit hard, right? Well, CPU, it's more of a game development type of stuff. Hey, thanks RKHS for the happy birthday. Yeah, man, I love this library. So let's get to it. So there's a few elements of PufferLib that we're gonna view. There's the Puffer tank, there's the ocean, and then there's like the library per se. Puffer tank is you should just think about it as like an abstraction with the Docker container to make just getting stuff ready much easier, right? It's very difficult to get all dependency right, because if you think about it, right, what we have in this stuff is like a full game. Like look at this stuff. Like there's a full game running over here, right? These guys are kind of in a deadlock right now, right? But like literally there's a game that is running at the moment. I think these guys are now like part of a clan or something. I don't know what they're doing. Oh, a bit of betrayal here. It's still running in the background, but like it's a game, right? It's literally a full game. But on top of the game, you have to make it like massively like kind of like customize the internal so that it's running fast in order for you to train agent. So you have the game stuff and then you have the ML stuff at the same time. very hard to pull off, right? So and then it's like it can get really messy. So Puffer Tank is this. Puffer Tank is like a way of like not having to mess around with dependency and all this. So if you want to get started, actually check out Puffer Tank, get the Docker stuff going, and then you can directly kind of get started with that. That's that. Thank you all, by the way, for all the happy birthday. Thank Will. Thank you, Mark. Very, very kind. Then you have Ocean, which is kind of like the collection of like environment that they are developing in C, and that they're all reviewed by Joseph, so that like it's making sure it play nice with everything. And there's a whole bunch of them. Like look at you even have like the version of Dota over here. You have like a driving simulator. You have a like drone thing going on, right? You have a Go game over here, the racing stuff, a bunch of Atari games over there. You have literally a RuneScape clone over here. There, it's pretty crazy, right? So pretty wild. And the problem that they saw is that like most of them are much too slow because they're not kind of well implemented. And like as the GPU get better and better, because this is already ongoing, the GPUs are getting better. Like the CPU performance for the environment is just gonna go worse and worse because they're gonna be the bottleneck. So he's trying to fix this as much as possible. Shipped a whole bunch of lines of C, much more than that. I think this is double at the time. And yeah, there's a whole bunch of them. You can check them out, right? You can go over here and have some fun with these games. Yeah, you can play RuneScape if you want to. Yeah, look at this whole gang. I don't know if they're friendly or something. A bit weird. I think it's gonna die, this one. Yeah, anyway. Once in a while, we're gonna catch up with what the character is doing here. Yeah, level 8, like, I think it's toasted for her. I don't think she's gonna make it. Yeah, and then like one of the key innovation here is that like deep down in the internal of this, it's made for speed, right? We're gonna look at it in a few seconds what exactly they did. But one specific thing that they did was that like he is changing the internal setup so that like the memory of the environment current state is shared between different processes doing different things, right? So there's less copy, the memory is less like being wasted in just copying stuff over and over again. Yeah. Hey, by the way, there's also like Fire Emblem and Doofus over there. I don't know if you guys played Doofus. back in my high school day, that was a hit game. All right, cool. So let's take a look at the PufferLib improvement. So there's three things. There's the emulation that is needed in order to do proper vectorization, which is needed to like do the rest and have like pretty good performance. They provide some model and they provide some like learning algorithm, but it's not the focus of the library. The focus of the library is making sure the environments are like super duper fast. So the problem currently is that most like learning libraries, so Gymnasium and then like Petting Zoo, they're made with Atari in mind, right? So like the Atari game. So it's a single agent, it's a flat tensor of observation, and like there's discrete action. It's not like this for everything, right? But if you have that, what you can do is you can like take all the information and flattening all of the observation into a tensor, an action to a single discrete, a multi-discrete variable. So you have what's going on, right, in the memory and whatever, but then you're emulating what's going on into like a tensor. So, and then this is the tensor that you're gonna do stuff with it, right? So kind of a compression going on. And then what you can do is like you can compress and decompress if you need like the stuff for like your forward pass of the model. And then this library, PufferLib, offer that. I think Petting Zoo doesn't. So it just compress it and then you're stuck with the compressed state. But the library can do this compression, decompression, and it helped with the learning stuff while making stuff much more faster. So here, Neural MMO provide isometric rendering, but the training API instead exposes local state data for each of a variable number of agent because it is 1,000 times faster, enabling user to train on desktop instead of supercomputer, right? This stuff has a drawback, right? So it has some overhead, which we can see over here, right? There is an overhead of emulation, but if you're doing emulation, you can also do the other stuff, the vectorization, much more easier. And this has also massive amount of improvement that it unlocks. right? So the second thing that they do, so they provide emulation by default here for the game that they have developed. And then the vectorization is like, if you don't know, it's the process of simulating many environment, usually on different core, which require aggregating observation, distributing action, right? So you're kind of doing like many simulation in parallel, and you're trying to make sure that like everything talk together, right? And this is where the concept of shared memory that I discussed here goes, because if you have proper vectorization, you have to be able to handle like this inter-process communication properly. We're not in a state where there's only one core that you can use. Usually, like even in research setting, like even in my days, like 7 years ago, like you have access to supercomputer in university. Usually, you can just go and use it. But like you have to put your stuff in a specific setup in order to like leverage the core. Leverage the core to do that. Vishesh says they are not friendly. Yasin, run. It's not me. I'm not doing anything. Like these guys are running. But our agent is doing well. Look at this. Like she's killing it. Like look at this. One dead. These guys are taking turn. I don't know what they're doing. There's a whole bunch of shovels she can take. This thing is learning well. Okay. Where were we? Okay, cool. Nice here. So the problem with like not doing this is that well, like you can't parallelize. So most of the library are actually like giving some implementation of vectorization, right? But usually it's slow and there's no support for complex environments. So they tried to do it with Neural MMO with Petting Zoo version. It kind of didn't work, so they kind of gave up on that. Yeah. So they provide serial multiprocessing and the Ray backend, so the Ray lib thing for the making the games, and there's a whole bunch of stuff that they provide through the vectorization, right? So you have native multi-agent support. You have an implementation of envpool, which is one of the main things that is doing a lot of speed up. But envpool is like something from 2022 that is like a C++ library. So you have to kind of write everything in C++, and you don't have any access in Python. But in their case, they were able to port it in Python and kind of do a Cython binding type of thing. So you have like this envpool functionality. And envpool basically is that like instead, like usually what you have is like sender vectorization simulate M environment in parallel and require waiting all of them before returning an observation, right? But PufferLib what can do is that you retrieve N that is much smaller than M. So you're like doing stuff asynchronously and then aggregating whatever you need. So if you set M to be 2N, simulation become approximately double buffered. It means that CPU core are processing half of the environment while the GPU compute action. So you're not like in a deadlock while you're doing your stuff. You can just kind of like use the GPUs much more than if you were just waiting and aggregating everything from the CPU. So it's not like a completely CPU locked at the moment. So this is super important for a complex environment, which have to have more branching logic path. Like here, like look, there's a whole lot going on, and like if you zoom out, there's a much more going on here also. You can do multiple environment per worker. You have a shared memory for like data communication, and they use like there's a lot of internal stuff they're doing. So instead, for example, they use pipe here, which are up to 10 times faster than Q for like in Python. So they're making sure that they're using the stuff that is the most optimized for like specific subtasks that you will not even think about, right? So bottom line here is like only one step per episode require any inter-process communication. Otherwise, all the processes are like going off on their own and they're doing great. They have shared flag for signaling, so this eliminates some of the inter-process communication overhead. You have zero copy batching, which is due because of the shared memory that you have. And then there's like there's 4 separate cases depending on your hardware that like make sense in order to run the RL environment. And what they like, there's you can check them out. But basically, what they say is that the PufferLib can figure it out for you with the autotune utility, which is fucking fantastic. So there's a whole bunch of stuff that you don't have to worry about because like Joseph spent hours and hours of his life figuring it out, right? There's a whole bunch of models that they have. I think it's like 4 or 5 There's a default one that you can use, especially for like testing and stuff. And like there's some optimization that he did with the LSTM that are worthwhile. So they like separate the encode and decode part of like the LSTM. All kind of like stuff that if you were to do RL research, you bump into them and then you mess up your stuff. Because remember, like RL environment is like game dev and then machine learning at the same time. So there's a big surface that you can fuck up your stuff. So he's taking like a big load to remove some of these issues here. So yeah, buffer model. There's also like, sorry, the learning algorithm here, right? The first party training with clean buffer RL. So it's basically just a PPO version. It's a clean RL version of PPO. It's getting updated from time to time to just make it faster, but it's not a library to kind of have optimized, like not optimized, but like different type of learning algorithm. There's one that you can use, but you can bring your own, and then that's pretty much that. So they're not gonna make a whole list of them for you. In terms of performance, pretty crazy. Like there's the emulation layer that add a few of overhead here, but generally it's not an issue. And with env-pool you get massive speed up. So they benchmark like these environment, and some of them don't work with the environment pooling, like this one, NetAC and MiniAC. And you see here the gymnasium version and then the SB3 stable baseline 3 version on two things, right? So on the desktop and on the laptop. And the desktop, I think it has 24 core, and the laptop has like 6 core, something like that. But look at this one. Look at the cart pool and then the ocean square, right? So they're like on the laptop, it's running at 200 like k step per second, right? So a step of like the environment. But on the desktop, it's 3 million. Compared to the gymnasium, like the speed up is insane. Like it's order of magnitude greater here. Out of the box, just with a wrapper, right? Wrapper, one-line wrapper around like around the stuff. So this is with the environment pooling, right? With multiple processes, and this is without, so you don't have this functionality. But you still have massive speed up here, kind of like 4 or 5 times we have a gymnasium and the SB3. So that's it. And then here, this is like the core. So you have 24 core for the desktop, and then you have 1 GPU here, and you have 6 core here, and then 1 GPU like that for this one. Hey, Senti, I hope you're doing good, man. Your daily is just joining after my daily stand. Don't get fired, dude. So yeah, that's it. That's a rough idea for PufferLib. I'm gonna make a more complete video with like example and stuff. But this is at the core of Neural MMO. And the guy has been working on this for a long while, right? And you don't see this often, like one dude just doing the same kind of field of technology over and over again. But whenever you see that, usually you have like a very optimized setup. Did we get? Oh wait, I think did we die? I think we died. I heard something. Yeah. Okay, sorry for that. I'm just shifting a bit. So yeah, if you think about it, there's other project that have only one guy that is doing it for like ever. Linux is that, right? There's just this one dude that like really like to make kernels. Yeah, like Joseph is this guy for RL. Pretty good. Check out his Twitter. He's always posting like very insightful things about RL in general, and it's good motivation also to see him like live streaming almost daily to make the library better and better, right? And he really liked to do this shit. So it's very cool, and very good community also around the project. Yeah, like they're very open, and if you're interested in RL in general and you want to get your hand dirty, you can go ahead and go help out over there by making your own environment over there. So that's that. I'm gonna ping my man, and we can get started with the the discussion right on time. Hey Joseph, how are you?
There we go. Can you hear me?
Yeah, man.
Perfect. On the cheapo
Fantastic.
phone again. Still can't get audio to work. It's great.
It's fine. We hear you well, and
Yeah.
yeah, we everybody. Can you hear Joseph properly? Ah, jeez. Yes, I think it should be good, right?
Hopefully.
I think we're good. Um, we have a few questions already, but like I'm
Mm-hmm.
gonna like take the questions and then like put it into the backlog, and
Sure.
as soon as I have the right moment, I'll be able to ask them. Don't hesitate, guys, to just put them down, and we'll be able to do it. So yeah, welcome, Joseph. Thank you for
Thank
taking the
you.
time. Thank you for taking the time to come here. Can you? I introduced you a bit, right, at the beginning. Can you just give us like a broader view about like your background in a nutshell, and also like right now, what you're working on that is very current.
Sure. You'll get the preview. It's gonna be pretty much the same story as the last one. I suppose a bit more on Neural MMO. So I've been working on making RL work in more and more complex and interesting environments for the last 7 or 8 years now. I did my whole PhD on Neural MMO, which we'll talk about today. It's a really complex environment, and now I'm working on using what I've learned in the process of doing that to make RL work more generally, faster, better across a ton of different environments, not just that one. I finished my PhD about a year and a half, a little over, a little more than that. And since then, I've been working on Puffer full time, trying to just bring those same advancements to everything and doing a whole bunch of speed and performance optimization along the way. And in the last year and a half, RL's really just gotten a lot more stable. It's actually starting to work very well now. But some of the problems that I originally set out to solve are still somewhat out of reach. So I think we'll have fun talking about exactly what's going on with that today. As for what I've been working on right now, I've been working on fighting the Torch C++ API. I'm working on a port of PufferLib to C++, at least the trainer. We're trying to really, really target some high throughput in the next release. And I'm sort of pulling out all the stops on low-level optimizations for that.
Cool, man. This is super cool. And what's the reason of trying to go in C++? Is there a specific like a client tell or like
Oh man,
use cases that you're hitting here?
I'm just sick of fighting with Torch compile, man. Like, we have this. eh, it just gets to a point where you wonder how on earth we end up here, right? So you have this library that's written in C++, all right, for training with CUDA binds. Okay, and now it's also bound to Python. Okay, except that you still need to do graph compilation in order to have your thing run fast because of Python overhead. So we introduced Torch compile to trace your Python code because we can't compile that even though we could compile C++, except it doesn't actually work and you can't trace all the things that you want to trace. And even if you do like make a complete mess of your code such that it's more complicated than the C++ and do get it to work, it's
Right.
still slower and now it takes 10 minutes to compile. Like, why are we using Python? Just why? This
Okay,
just
cool.
drives me insane.
Yeah, yeah.
So these are the
This,
types of things I just like.
yeah, yeah. And so, are you gonna move the whole thing to C++, or are you gonna like
Oh, of
dual?
course not. Nobody will use
Okay,
it. Nobody will
yeah,
use it if I do. What I'm doing is I am trying to write a test essentially asserting that the Python and the C++ backends are identical, and it's
right.
really only going to be a couple hundred lines of code in either case difference for the core algorithm implementation. And we're going to start timing some speed differences. And my expectation is what's going to happen is that for like really, really high data regime stuff, the perf is going to be a little bit better. But for the lower data regime stuff, it's going to be the case that the sort of sample efficient experiments are just going to get 10 times faster because you're really just dominated by like a launch overhead.
Right, right. Okay. That makes a lot of sense. Yeah.
Yeah, but it's kind of funny that this is the type of stuff I end up doing because, like, how do you get from big fancy multi-agent M's to this? And it turns out that the way to make all this stuff work is just pure performance engineering a lot of the time.
Yeah. Yeah. There's somebody that asked, Patrick is asking, was Rust really slower than the C++ implementation? I think in the paper, PufferLib 2.0, you said that like there's some part of it that you tried to write in Rust, tried to write in C++, but like the environment in C was much more.
I'm gonna be honest, I didn't try very hard on the Rust one. I just hate Rust. I just do not enjoy that language. That does not bring joy. Okay.
Okay, that's
but you know what? I'll be fair to you. I'm not saying that C++ is good. I hate C++ too. I wish that we could just have a very thin C wrapper for Torch. Like, yes, there's CUDA C++, sure, but if we could just have a nice C-style API, get access to all those low-level components. I'll even give up AutoGrad. I don't need AutoGrad. Okay, I can write the same thing and write dot backwards on each of them. It's a lot easier than what I'm dealing with now. But yeah, there's just no good backend for anything. I don't even think anything good has a reasonable C backend. Maybe TensorFlow does, but then you're dealing with TensorFlow, which is dark ages.
Yeah. That's even worse. I think PyTorch related. We have a few cool questions that are not more related to you because. Like for context, I think it was 2 days ago or something like that. Like I was on Twitter and then I was posting something, but then I came to your stream and you were not at the desk. You were in the background trying, like doing deadlift. So,
yeah.
There's a question about. Right. There's a question about what is your deadlift 1 rep max? That's Yannick that is asking this.
1 rep max is. I don't have a 1 rep max. I got a 2 rep max. I have. You can find the video if you just look in my articles. So my best total is 1,000. If you're counting belt and straps, 410 for 2 deadlift. I can't pull that now because I'm about 20 pounds lighter. But right now, just yesterday, I did a couple sets of 5 raw, no belt, no straps. For 365. So 365 for 5. I weigh just under 170 right now. And I'm trying to get back up to 4 plates without putting too much weight back on.
Okay, man. Is there a reason why you're not gonna go full bulking mode, or?
There's like a longer thing. I wrote this long health article. I had a really severe bout of pneumonia. I lost a ton of weight.
Right.
And I put some weight back on because I lost the weight and I got kind of chunky in the process of that. So then I had to cut a whole bunch, and now I'm kind of just putting weight back on slowly.
Smart.
And I also run a bunch as well. I also run a bunch, so it's hybrid.
No, there's nothing worse than being very bulky and running. Also, you feel like you're.
It sucks. Oh, it
sucks. You feel like you're in a nightmare almost, like trying to run in your dream or something like that. I used to do a lot of competitive swimming. And during the summer, I swam less, but like I ate the same. So I was just getting heavier, and I was going to the gym. But when it was time to go back to the pool and just do the cardio stuff and running, I felt like I was dying every day. It was fucking crazy.
Yeah, it's terrible.
So with this being said, there's another question about your.
Where's the chat you're pulling from as well, so I can read these.
Yeah. So wait, there's one on YouTube and there's one on Twitter. Actually, I can.
All right, let me go find your. Yeah. Oh yeah, you're like Restream or something.
I'm streaming on both of them, but also I have questions from a bunch of posts that I've done. So this is from a post. Is Dionysup that asked, what is his approach to periodization, bone dark choke or something else? What do you have?
Wait, are these all fitness questions?
I just pulled up all the fitness questions.
Wait, what on earth? What is this? I was supposed to be talking about. Oh, hang on, let me find the. All right, cool. So we've got this. Do you have an RL beats? Why is this all fitness? My God.
I didn't choose the question.
Look, guys. All right, look, guys. The fitness, the whole fitness thing. Let me give you something a little bit about this, like why I do all this stuff. So first of all, I'm not a gifted athlete at all. All right, I was like the skinny, scrawny guy in high school, like bottom 10-20% and stuff. But as I've gotten, more into research and more into just like independent out there stuff, research is very uncertain. You can be completely world class and you'll have bad weeks, you'll have bad days, you'll have bad months, right,
Yeah.
in research. So it's very important to have a counterbalance, that something is very consistent, that something that builds and demonstrates discipline, and that gives you a constant. So when things are going bad, it's like, look, I'm putting all the effort I possibly can into this. This is simply the way that research goes. And when you sort of burn yourself out for a couple weeks, which happens quite often in research, it kind of just gives you the mindset to say, I can step away from this for a couple weeks, and I know I'm going to be able to come back to this fresh, because I've proven to myself that I have the discipline to go through this, right? And I'm not just being lazy. Um, it's a very, very important mental thing I found in my research. I really wouldn't be able to do the type of stuff I can. So what I try to do for the most part, right, is I stream all my research, I stream all the dev I'm doing, but I include a little bit of fitness stuff now and again, because I think it's very helpful to people in this space, and far too many people in our field don't do it, and it's hard, but it's very achievable, right?
Yeah.
Yeah.
Also, from a pure like neurological perspective, it do help a lot with neurogenesis, right? So keep your brain a bit more plastic.
Mm-hmm.
So kids out there, go and lift some weight, run a bit, especially in between like difficult problem that you're trying to fix up. It does help a lot. Okay, so those are the yeah, we're done with the the deadlifting and the workout question. We can go into the more academic ones. We have another question. Sorry for your live streaming. So Will is asking, how has live streaming helped you with accountability? Was it always this crack, or does live streaming help him stay task focused? Because also it's very like coming from a academic background, it's also very rare to see somebody like share so openly what the
Mm-hmm.
heck they're working on, because like everybody's afraid of getting scooped at whatever it is. I think in your case a bit less because it's a lot of engineering stuff, but very rare that you see just someone go straight on stream and just say like, hey, I'm working on that, and like can ask a
Mm-hmm.
question. So what do you think, what is live streaming for you on this front?
I mean, it's pretty much just been all upside. So first of all, it actually helps me stay focused. So I save about as much time as I spend interacting with chat, because otherwise I space out, I get easily distracted. Right? So it actually does help me stay on task as well. It's enjoyable. Um, I get tons of new people interested in the project and contributing to the open source
True,
from
true,
this,
true.
and I get to, I mentor people as well in the process. So it's great with that. And then also, otherwise, research is very isolating, right? Like, imagine if I weren't doing the streaming, there would legitimately be like multiple week sessions, periods straight, where I just don't talk to anybody.
Yeah.
Um, right? I'm kind of very intentionally out here in the middle of nowhere, focused on my work. And you just completely lose the ability to speak in complete sentences if you do that without any sort of counterbalance. So this prevents that from happening as well. It's pretty much all upsides.
Yeah, yeah. It's the sentence thing is actually very fucking true, because I experienced it myself when I was just like head down into one stuff in my
Yeah.
lab, and then I had to present on a poster. Jesus, I couldn't
Yeah, it's a
talk,
disaster. I've had that happen, that exact thing happen before.
and
And it's
like
like so obnoxious too, right? Because the
you look like
loudmouths
an
that don't
idiot.
actually build anything, they talk all day. So they're
Yeah,
always going to present something, very convincing, even if they have nothing. So
yeah,
if you're
yeah.
actually building real stuff, you also need to be able to present it, or you just get crowded out in the noise.
No, definitely. And if you're in conference, I found that like the best talk is almost the one that is incomprehensible. Like the guy is talking a bit in his head and stuff, and like the deck is a fucking mess, right? But like you see, there's something there. Um,
Mm,
yeah, that's how you find the gems. Okay, we have
mhm.
a whole bunch of questions, but I want to go and move to the Neural MMO V3. We have
Mhm.
maybe I can show you the. Can I just like go here and will this work? Wait, this is a window. Okay, if I go there, you can see this, And so can you see my screen? Okay, perfect. So you can see it, but nobody in this in the chat can see it, but they can see my stream over there. So that's good. So Neural MMO, can you walk us through a bit what it is? We're seeing here an agent that is doing whatever the agent is. I think it's just like firing arrows and stuff.
Yeah, it's
This
kind of just chilling at the moment because there's not really much incentive for it to. People always ask about like why agents jitter and do weird stuff. It's because
yeah.
there's no reason not to, right? Like there's no incentive in the environment for them not to. Like smooth movement and just like stand in place. That's a human concept. It doesn't cost anything.
So if there was a concept of like energy or stuff like that, that this will cancel out and like it will not do a bit like in Stardew. The more you do stuff, the more like your energy bar goes down. And at some point, you can't move at all. So if there was this element, maybe they will stop like just firing in the void.
Yeah, you can do that. You just have to balance it against like, you can mess up the ability to get to the actual reward if you do that wrong. But that's totally a thing that you can do. And you can add all sorts of smoothness penalties as well. So let's see, what is this agent that we have here? What level is that? So let's say 4/8.
Yeah.
Is that what it says? Okay, cool. So this is like a miniature MMO, right? At the bottom, you see its inventory. This thing currently, it's level 4 in combat. It's level 8 in gathering, foraging. So it just took all the combats, put it into one level, all the skills, put it into one level, simplified system. You can see it has a few tools, and then the highlighted ones, it has equipped this like gem, which is an aspect. It has equipped a bow, and it's also gone and found itself a chest plate. So in order to do this, you can also, if you just hit control once, you can take over for the agent.
Control 1.
Yeah. If you've already clicked over the window.
Can I wait? No, I think.
Does it work?
You said control 1.
If you control once, if you just tap control once.
Oh, okay. Sorry. Yes. Yee-hee! Oh,
Does he stop firing?
Wait a second. Oh yes, I can. I think this is me. My computer is currently trying its best.
Okay.
So here we are. Yes, this is. We're gonna move a bit the environment.
You're able to walk around? Yeah. Okay. Cool.
So if I put it
here. Oh no, it's so laggy. I need to fix that. So the thing that's lagging there is the fact that the neural net that I use to control the agents is just like a super janky pure C implementation of the PyTorch neural net that was trained on one thread of CPU. And I only optimized that to run well on like a good desktop, because it's actually, the neural net got to be kind of big. It's like a 2 or 3 million param network with some comms and stuff running on one CPU thread. Okay. Yeah, but anyways with this, so the idea is you can wander around, you fight enemies, enemies drop tools, you can pick up the tools, equip the tools. There are different qualities of tools. Different qualities of tools let you harvest different qualities of resources. You get different gear from different resources. You equip gear. There are a couple different weapons. You can trade, buy and sell all these things on a global market with other agents.
Yeah, we just saw
miniature
it. Like,
MMO.
Go into a buy mode, like you're here. Like
yeah.
Is buying?
Yep. It's a buy mode.
I had a question with this. Like, who is it trading with? Like the other agent?
Yeah, the other agents. So because it's the browser mode demo, right, and it's running on CPU, there are not 1,000 agents in this map. But during training, we'd have 1,000 other agents running around in the same map for it to trade with, in addition to all those enemies and stuff, right? So it can trade with those other agents. You can see over time that it actually learns to trade a little bit, to buy and sell stuff. And that's the genre it was modeled off of, right? The real progression and at the level of a server, the real progression in an MMO all happens through the economy.
Right. True. So we learned from RuneScape. This is a question I wanted to ask. Like, I think you said it in your PhD defense, but like for others that are not aware, why have you chosen MMO in particular to model complex environment?
This was, man. This is sounds a little over the top, but most of research is not like Eureka, I've got it. This was absolutely Eureka, I've got it. I came up with this idea properly, I think, right before my sophomore summer year of undergrad, so quite a
Okay.
while ago at this point. And I was, RL was starting to become big at the time. There'd already been the Atari work. We were
Right.
starting to see like there was Go, and we were starting to get like inklings of Dota and stuff. Um, and I was just thinking, man, this RL thing is really cool. You can solve these arcade games. You're solving really starting to solve much harder games. Well, then what's the next thing that we can solve, right? What is going to be the real big benchmark um, to see whether these algorithms give us self-contained intelligence or not? And I was playing RuneScape at the time, as you do in undergrad. Uh, and I was just thinking, man, what I'm doing in this game is completely stupid, right? Like I'm just clicking on a tree to cut a tree.
Yeah.
What the hell am I doing? And then I think, well, okay, but actually you're cutting this tree so that you level up this thing, so that you can go finish this quest, you can get this other item that you need to do, and like, oh, okay, that's what AI can't do, right? That like crazy chain of reasoning in this self-contained world. And it kind of just became obvious that there is no other genre that we have, and really not even outside of games, there's nothing that we have either that we know how to
Yeah.
actually simulate. Because people can say the other big competing hypothesis at the time was, what if we just simulate the real world? But we don't know how to do that. We do know how to
Yeah.
simulate games, and MMOs are also the fastest to simulate, right? They were built to run on 90s hardware, cities of players on 90s hardware. Um, so it was just this perfect storm for AI. And RuneScape in particular, the architecture of that game internally is really, really good for building a fast, scalable world sim. Um, so that's where the idea came from. It turned out to be a lot of engineering, and it also turned out that all of the tools that existed in RL at the time were absolutely not built with something this scale in mind. And I spent a lot of time just getting even the most basic things now that are obvious to me, getting those set up, and the project just kept going from there. I didn't expect to do this for this long either, because in my mind it was so obvious. Well, no,
Yeah.
seriously, in my mind it was so obvious that I expected OpenAI or DeepMind, right, to like go do Dota and StarCraft, and then the next obvious thing is that
Yeah.
probably DeepMind was going to go get a Blizzard partnership and solve World of Warcraft, or like RuneScape, or one of them, and then they just didn't. So,
And
okay,
for
I'll do it.
on this front, like because I was also a bit surprised because when like the StarCraft RL agent came out, I was like, this we're done, guys. Like I
Hmm.
don't know, man. I mean, like next step is what? Like you've done StarCraft, like yeah, we're getting there. I think it's something that is truly intelligent that can like manage multiple things, multiple state on like complex
Hmm.
map. Um, because I played StarCraft and I fucking sucked. So I was like, yeah,
Yeah.
this thing is clearly better than me, and like it is able to handle like all of this difficulty. I think for me was much more of a big like okay, yes, it's gonna like it's going into the direction then the game go, because I didn't knew that much, and for me it looked like chess, which is more bounded. But why didn't they go this route and push it that much, you think?
LLMs. LLMs just took over everything, you know? Still a few of us here doing the stuff, and it's actually the cool thing is because I'm doing this the way I'm doing it now, it's going to work and it's not going to have to work behind closed doors. It's going to work like on
Right.
your home computer, which is pretty sweet. Um, but yeah, it set everything back a whole bunch of years. I mean, the Dota team was the best team I'd ever seen. I was working on Neural MMO there, just interning for a little bit, and it was the coolest project I'd ever seen. I like Dota more than StarCraft because OpenAI solved that game with simpler methods, and it is a team game. It's not 1v1.
Right.
But where do we go from there? Well, both of those are round-based games with no meta progression. Right? You're solving a task on the span of an hour. I think the complexity that goes from StarCraft or Dota to an MMO is like at least the same as the complexity from Atari to StarCraft or Dota. It's like the same order of magnitude jump. And it's not because the gameplay is so much more complex. It's because of the totality of what is happening on an entire server over time, right? You turn the server on and it keeps going for 2 decades, and you
Right.
keep seeing new
True.
things happen, right? That's
Right.
really like open-endedness in a nutshell. And it's like every possible form of reasoning and strategy and interaction. There's just so many different incentives. They're very self-contained as well. Um, and that was what I was originally working towards, right? It turns out it's a lot of engineering. It turns out there's a lot to get right with the RL. The RL is actually getting pretty good now. Um, there's still some things that we need. I don't think we're there where we would just like let it go and it would solve an MMO yet. I don't think it's quite there. But we are starting to put together the pieces.
Right. There's on this front, Caravas is asking a question. Why did you decide to pursue RL at MIT? And were there any other research question you found interesting, like as you were like getting to explore that facet?
No, by then it was a foregone conclusion, right? Like
Okay.
I'd spent a year in NLP, I'd spent a little bit of time in Vision. I'd already been doing RL and Neural MMO for a couple years. I did it at OpenAI for a bit, and then I followed Philip, who I worked with there, to MIT because he became a professor. So he was my advisor there, and the deal was, yeah, I'm going to do Neural MMO for 5 years, which is kind of an unconventional thing to do. Usually, you float around for a couple of years.
Yeah, yeah.
Um, but yeah, that's what I
Usually
did,
you
and
don't
that's what I
know.
did.
Usually you don't know even what your
Hmm.
thesis will be about for like, I don't know, like 2 years or something, and then like
Hmm.
kind of form it. But in your case, you wanted to do that shit, and you ended up doing that stuff, and it's still going.
Yeah, yeah, it's still going.
Yeah, you're a man of sheer will. There's
The
another
progress is way
runes.
faster now as well. Like it's not, it's like it doesn't feel like I'm just plodding along either anymore. It
Right,
actually feels like there's really rapid progress and the gap is closing quickly now.
right, and because you think that like most of the blockers are like just engineering things that like slow us down.
A good chunk of them are, I will say. So we are going to have, so we already have 100x training speed on on the full MMO versus my PhD. Other areas we have 1000x. So I think if we can get it to like closer to that 1000x speed up, we should be good. Because at that point we can just crunch. We can already crunch petabytes, but like if we can get a 100 petabyte run type thing, we can just fully automate sweeps. Right now, Neural
Right.
MMO is the only M for which it's hard to do full sweeps because it actually takes quite a while. So that's going to help. And then I think at some point we're just going to solve Neural MMO 3, which is not the same as solving the full thing, and we'll have to make Neural MMO 4. And Neural MMO 4 is going to be even better because Neural MMO 3 was really just like the first big env I threw together in C. And I know a lot more now. And yeah, there's some differences with how I would do stuff. There's at least, I think there are at least one or two major algorithmic upgrades that we're going to need though, but I could be wrong. I think
Yeah.
there are going to be at least one though, at least one major algorithmic upgrade
Okay.
before then.
There's two questions related to RuneScape. The first one: how far are we from having agent pickup from level 3 on RuneScape all the way to finding out the best optimal path to endgame? This is okay. That's asked that.
Yeah, so this was like the crackpot crazy thing, right, that I sort of came up with back then, was that I saw this as an alternate path to AGI. Because if you do that, you have AGI, right? There's
True.
just no way in hell, right? Like what the hell can't it do? We don't have anything that works that way now,
Yeah.
right?
Yeah.
Like I guess could you run an LLM and have it do that? Probably not. Even if you did, it would be so stupidly slow, it would just be pathetic. Um, yeah, I don't think you would get it out of an LLM at all. And actually, even if you do, it's like you'd have to. The problem is LLMs are kind of poisoned because they're optimized to like things that we already know. So you'd have to make an unintuitive
True.
MMO, right? To like see if it really generalizes. The power of RL is the fact that like if it solves this thing, it's not that like it just solves this MMO that's something that we recognize. It's that it solved a really hard fiddly optimization problem along the
Yeah.
way. So we can. The difference is if you throw an LLM at it and the LLM would work, like that doesn't mean the LLM is going to go be able to solve all sorts of unintuitive things, right?
True. True. Because you
Scientific
can just
simulation,
look
material
up all
science,
of
like
the
robotics. Yeah.
Yeah, you can just
But
look
if you
up
have
all of
something from
the
scratch,
RuneScape wiki and then figure out
yeah.
like the different path for all the quests and shit like that.
But if you have something that can figure out just like a problem that hard from scratch, it just solves everything, right? There's no way. There's no way that you solve that specific problem and you don't solve everything else.
And do you think a bit tangential? I know that Arc, AGI, they're going into the game route. Do you think they're seeing the same? Because I think they're building game like benchmark and shit like that. Do you think they're going into the
Tiny,
same?
tiny, tiny, tiny fraction, right? Like this is the problem is all the LLM evals are always going to be stunted, or at least they're going to be like stunted by a decade because the stupid models are so slow. Like, what are you going to do? And that, if you want here, if you want a hard game that's relatively fast, that's probably AI complete, go solve NetHack,
Right.
right?
Cool.
Like that would be that's a real benchmark, right? That's like that thing is not the complexity of a full MMO because it's missing the multi-agent component, but as far as single agent tasks go, that's the best one.
Right. Right. Um, cool. We have one last question on RuneScape. Then we're gonna move on to like the a bit of the core stuff. On the connection to RuneScape, what reward structure in Neural MMO v3 prevent grinding one thing like wood cutting, like in RuneScape and stuff like that?
Well, that's kind of part of the game in RuneScape, but it's so the design of
Sure.
Neural MMO 3, it's a much simplified MMO, but the idea is that you only level up to a certain extent from a certain type of resource. So it's like you go defeat low level enemies, you go level up as much as you can on tier 1 resources, 8 levels or whatever, and then you have to go get armor using that, fight like a harder set of opponents, and then there are 5 tiers of this back and forth. So there's some amount of progression. It's sort of cyclical. And yeah, I mean, as simple as that is, that's already like a harder and better benchmark than some other multi-agent stuff out there.
And I think that in the V2 there was much more like skill tree and skill that you could level
Yeah,
up,
there
but
were,
you
but
simplified
like
it, right?
I don't I merged it. I don't honestly think it simplifies very much
Okay.
because like I just had separate skills for each resource, and then I just combined them into one XP bar for foraging and one XP bar for
Right.
combat. And then the trade-off is the combat system now is better, the equipment system is now better, the trading system is now better. So overall, I think Neural MMO 3 is a bit more complex than Neural MMO 2, but it's not a direct superset.
Okay. Okay. Cool.
Yeah.
Okay. So this is that. We can move on to we still have time. Other question. So in Neural MMO V3, V2, this was part of your thesis and stuff. And if you think about it, it's literally a whole bunch of game dev type of work,
Mm-hmm.
plus the normal machine learning type of work that you expect from researcher. And on top of that, you have to make
Mm-hmm.
this thing like performant, because it's not just you that is running it at like, I don't know, 30 frame per second. You need to go fast, right?
Yeah.
How, just conceptually, right? Like, let's say you start from a blank slate. How did you go about like building this? Like, what was your like rough like flow that you went to?
Very inefficiently. Okay, so when I started this, right, I didn't even know I was going to do RL with it necessarily. I knew that we were going to have the environment, so I just sort of wrote some basic looking game. Then I realized, oh, okay, shoot, we have this observation and action space problem. Honestly, there were so many things. Like at one point, I wasn't even sure if we were going to run the full game on one core, if we were going to need to multi-core per instance of it. Um, there were so many weird questions back then. But let's say once we got past the really initial questions, the sort of the big ones were how do we design something that has reasonable enough observation and action spaces while still being expressive? How do we make a performance target for this thing that is 100 times higher than, at least 10 to 100 times higher than an actual MMO? And then how do we set this thing up to ask interesting research questions when RL at the time still really didn't just work? And yeah, that was really hard. So the design I had during my PhD that I got to sort of early on was that we had a NumPy backed set of operations for a lot of things. So a lot of the ops for the env were like, especially the observation computations were vectorized over NumPy. And I got the env up to like 3,000 maybe steps per second per core from that, which was probably the best thing out there at the time. It's pathetically slow by puffer standards today, but it was pretty good for the time. The obs and action spaces, the design I converged on back then was like this 2-tier system where it was like an entity representation. Everything that you see in the world is an entity. Each entity is a collection of attributes. So this gives you this sort of 2-layer encoding network for that. And then the actions were a little tricky because you had like pointer networks to select entities to target, right, for attacks and stuff. And that was the design I sort of converged on in Neural MMO 2. And that thing worked, but it was so annoying that I just axed it in Neural MMO 3. And instead, the major insight for Neural MMO 3 was, what if I just wrote this thing as if it were to come out on the Game Boy Advance? Just
Okay.
like, you can implement whatever you want for whatever hardware. So I'm just going to make the game be played with a small set of buttons. And that resolved the action space issue. And then for the observation space, I kind of punted a little bit and just made it like multi-channel, not an image, but like a multi-channel tile-based thing. And at least that gave me a fairly compact obs representation that works with convs instead of a super fancy architecture. And I got the action representation to be good. I don't think this is ideal yet either, but it was way better than what I got before. Those are at
Right.
least some of the things I thought of along the way of dealing with this. On the research side, it was pretty much like whatever interesting things I happen to find in the process of developing this, see if I can publish something about it. I always wanted to just do more engineering.
Yeah.
Of course, academia wants you to do more science. And then I think I've been proven right, at least in the last year and a half, because all the results have been from me just doing way more engineering.
Yeah, 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 and just doing stuff also like
Uh,
um, um, it's a bit tangential here, but I was at the TRM lecture at Mila yesterday, and
mm-hmm,
what was very funny is like Alexia is absolutely fantastic, but she haven't didn't read the Universal Transformer paper. She didn't read the CTM paper, whatever. She just made the shit work. And like the interesting bit is that every time somebody had a question or like oh, have you tried this? Did you think about this? The answer she was like, yeah, I tested it like this, and then like it didn't work. But like at the end, she was like, yeah, we still need to understand why it's working, and she pointed to her colleague. She's like, he's the one working on it, which I think has a lot of merit. Like there's a separation between like the theory and then actually making a discovery that is
mm-hmm,
sizable and that has some profound like relevance to it, but like you don't need to like have the precise mathematical like derivation or whatever or the flow, but like why it's working is just fucking work. And like the other thing that haven't worked, well, we tried them out, right? We
mm-hmm,
blitzed through the CPU GPUs, and like this is what we discovered from it. I think ML as a field, there's a lot of this. There's a lot of like, we just went and then actually like we think this will be useful. We tested it. It is useful or is it not useful? And if you think about that in this sense, a lot of the problem becomes now an engineering problem because you just need to test it out, right? You think that this particular architecture will be useful for whatever, go ahead, right? But if it's fucking slow, then you're gonna fall back to the theory, which I mean, at some point the theory is always lagging, right? Like, we don't know
mm-hmm.
why some of the stuff worked, but like, if you're always just waiting for this, then you develop your big thing and then you let it run. You're just gonna slow down progress in general.
It's
Um,
kind of funny because the calculation that you run to see if stuff is as fast as it should be is really easy. Like you just divide flops of your net by flops listed on GPU, and then you see that you're at like 0.001%, and then somehow it never occurs to our field for 10 years that probably we should change something about this. And like, yeah, you fall back on the theory if the thing is slow, but also like, all right, did you really, even try to make it fast because these like you're running it like you're running it at the same speed it should run on a Pentium CPU.
Yeah, 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 yeah.
Right.
But I mean, like to the defense of the of researcher in general, it's another set of skill,
Yeah, it's a
which
totally another
I
set of
rarely
skills.
I rarely seen in like in research that have both of them, right?
Well, it depends what
Um,
you value, right? Like, I didn't set out to be an engineer. I set out to do research and like advance the field. And then I went and I got the skill set that was useful to that, right?
True. On that front, we have a question about uh, do, 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 wait. What are the core bits of optimization that you injected? Let's say if you had to choose like one or two in your MMO that made it possible to go like that fast on something as
Mm-hmm.
complex as this.
So one is if you just write stuff in brain dead C, uh, it turns out that's actually your base speed. It's very hard to make things slow when you do that. And people have kind of just forgotten because they're used to writing their for loops in Python. And there's at least 100x speed difference just from that. It's usually bigger. No dynamic memory allocations is typically a good one. And then the other really big thing is that when we're writing observations in all of our M's, they're getting written directly into shared memory that's available on the main thread. So we're not like redundantly copying gigabytes of observations per second.
Right. Okay, so that makes a lot of sense, and I think it's aligned
Mm-hmm.
with what you already
Yeah.
mentioned in PufferLib. So like if we like how saturated is this kind of like environment right now? Like what are the
About a
benchmark
third.
roughly that okay,
About a third of the way there.
okay,
I think we'll
and
solve this one at some point without going too crazy on the algorithm side. I wouldn't be surprised if we just solve this at some point. Um, but you know, the next version will be harder, right? And so
right,
far, this is our hardest benchmark. We don't have anything that scales this well because you know we have for every single environment we have full hyperparameter sweeps, including network sizes for most of them, and you can see the sort of the Pareto curve of cost, so compute invested or steps invested, whatever, versus outcome and environment. And most of them they'll level off or whatever, right? You either solve or you plateau. And Neural MMO 3 has a perfect log linear curve for 650 billion steps. And nobody runs 650 billion step observation experiments unless you're Google or DeepMind. Like literally nobody. Well, DeepMind or OpenAI back in the day, literally nobody does that. And most of the
right.
time, even they don't do that. Um, so yeah, that's pretty solid scaling. It's like 13,000 years of games, right?
Jesus, man.
It's a lot of games.
And you mentioned earlier on that like there's gonna need to be some algorithmic upgrade and
Mm-hmm.
whatever. Caravas is asking this. So he said we need one or two more. Do you have an idea, like what they are roughly, or
Yeah, I have a couple ideas. There's something around exploration where the problem is that most of the exploration literature is really bad. Like it
right,
doesn't even define, it sort of fails from the abstract because they don't define the problem correctly. Um, but I don't like the way that our RL algorithms sort of just latch on to one objective and they don't try anything else. And I think that is at the algorithm level. Like you can solve that at the environment level as well, but I think we can actually fix that at the algorithm level if we try. And then the other one is just like sparsity, like really, really heavy sparsity. And I think we know how to solve that, but it's going to require us to change the way we write our simulators just a little bit. And
okay,
it has to do with settable environment state. You can check out the Pokemon blog post. I think like stuff sort of similar to that is going to end up being used.
right, and um,
It's probably running on 4090s. Yes, the Neural MMO was running on 4090s. Yeah.
yeah, that makes a lot of sense. Um, so we have a so we're still like um, a way a full way there, and a bit of a also a tangential question here. Um,
Mm-hmm.
Based on this, right, with your current benchmark, do you think like
Mm-hmm.
just a LM with tons of compute could it solve it, or it's not even possible here?
Maybe.
Because there's no real documentation about the strat, whatever it is.
Yeah,
Um,
maybe. But in my mind, it doesn't matter, right? Like in my mind, I don't really care. Um, I mean, it definitely can't solve it if you just give it the state, right? If I just say, here's the block of numbers,
yeah,
right? Um, yeah. I have a different objective with this than the LLM people do. So like honestly, I expect LLMs to do really well on a lot of like the interfaces, at least for which they provide text or images or whatever in the next few years. And like I honestly like don't care because it doesn't change really the reason I'm doing this. It's not like a competing approach even.
right. Okay,
And,
that makes a lot of sense. We have a few more questions on. We actually have a fuckload of questions. I'm gonna filter them out. Okay, so there's one question about if PufferLib can be applied to non-video game or LM-based industry problem. Yeah, do you think that? Well, actually, I think this is. Yeah, I think it's a yes. But go ahead. You think that it can be applied to non-video game or LM-based like environment or problems?
so we explicitly don't bother doing LLM stuff, but yeah, pretty much everything not LLM that's outside of games is yeah, valid. And we've done some stuff in finance. There's some stuff in like animation. We're looking at some stuff in games as well. Like, um, I think there's another question there about logistics. That's a pretty clear target. We haven't done anything in that space
Right.
yet, but that's a pretty clear target. And then the big one that I'm interested in that's just going to take a little bit more advancement on the RL side to really do correctly is scientific simulation.
Okay.
The usage of simulators in science. That's my really big one in the real world. Yeah.
So,
I mean,
to,
it's
to,
it's kind of funny to me. Like people just say like, "Oh yeah, RL is only good for games," and it's just like a completely stupid statement because it's like we use games because they're interpretable. So they're good targets for research because we can tell what the hell the agent is doing when we're doing research and stuff is breaking, right? The agent doesn't care that it's playing a game. Like I
true.
go point it at a drone sim, it solves it in 30 seconds. I go point it at some finance ends, it solves them in 30 seconds. Like it really doesn't care, right? And that's the point. And it
Yeah.
is actually that robust now as well. Like
Geez.
it's not like we have to tune it at all. Like most of the time we make a new M that just solves it out of the box.
That's pretty intense. And can you just give us a bit more uh, uh, color and example on like the scientific simulator? Like exactly what you mean by that? Do you have an example?
I mean, the one that's really kind of obvious to me is material science simulation.
Mm.
Um, it's in general the idea of what if simulation is not a tool in which you set up initial conditions, you press a button, and you see what happens, but simulation is instead an interactive process where you specify the outcome that you want in simulation, you
Mm.
optimize towards it, and then you look at the path taken to get there. That
Right.
makes simulation as a tool something much, much more powerful, and it is completely reliant on having really, really good RL.
Okay, that's pretty. It's pretty
Mhm.
dope.
Yeah,
Are
so that's
you?
my big objective with it.
Yeah. Are you thinking on creating some environment that are based on that and add it, I don't know, to ocean and whatever?
Yeah,
Um,
absolutely. So for now, new environments for now have to either be from clients or from like interested contributors, because I still have a lot to do on core reinforcement learning. It's still going to
right.
take at least like another year to have RL to where it really, really should be. But yeah, the idea is once I have RL to the point where I think, okay, this is a mature technology, like this just works on everything, this can solve really hard problems out of the box, then I'm probably going to start picking domains where I think this can make a huge difference and start building big sims, right?
Right. Okay, man, this is exciting. We
Mhm.
have another one about RLVR and the potential of RL used in automated theorem proving. Are there any theoretical or engineering innovation needed in order to do that?
I don't have any experience in that area. Presumably language models of some part are needed there. I don't actually know what the symbol language looks like. Yeah, I don't know enough about that area. It's kind of like a weird in between where like portions of that you could probably make a fast sim in RL, but other portions of it like are areas where you'd really like to capture human intuition.
Hmm.
So it's kind of like a weird in between, and I don't know enough about that area.
Yeah, me neither. So sorry,
Hmm.
TJ, we can't answer this one. We have one last one. I think after that I think we're good to go. Um, it's RKH that asks. I always wanted to set up an environment to train a realistic 3D snake model to move like a snake. Any
Hmm.
suggestion on a good way to start on it? Any good existing environment?
This is like just a snake, not Snake the game, I presume.
It's literally just a snake.
And it's the control environment, so it's just some sort of soft body physics. Might be, it might not have to be. I mean, like the two things you would either do, right, would be to grab like MJX or something and try to set up a scene and then set it up as an RL task. Or I don't know how hard the physics in that if you can just do it yourself from scratch. Like we have a drone end from scratch. We've had a couple people build other physics ends just from scratch, just like write the physics update rules in C, and it turns out to not be that long a lot of the time. Um, you just do one of those two things and expose the you'd probably just expose, well, I guess it depends how you're modeling it. You'd expose probably like the forces or something directly. Um, yeah, or the muscle tension. No, not muscle tension. Probably just like the forces on the joints that you're modeling as the action space. But then to get it to move like a real snake, then you act, well, there are two ways to do it, right? You either have to go get some data on how snakes move, or
Yeah,
you have to make the environment close enough to the constraints of the real world that like,
exactly.
snakes move that way for a reason, right? So you actually have to make it pretty close to true. And then you just the trick with that is then you have to figure out one how to do that and two how to cut all the corners that make the
Yeah.
sim slow that you don't actually care about. That's a lot of like simulation. It's just figuring out what things you actually need to sim to get the outcome you want, and what things are just slow and not actually that related to the learning signal.
Yeah, yeah, yeah. RKHS. It's a lot of engineering. I don't know why you want to do
Yeah.
that, but like, I think it's a good problem also. You maybe like try
A
to make
fish
it
would be
climb a
easier.
tree. Yeah. Yeah, true, true. You can try to make it climb a tree because it has to kind of have all of the forces properly if it's long enough and
It's
stuff.
probably pretty hard.
Yeah, I don't know what fucking
Yeah.
type of snakes you're looking at. So, cool. Thank you. That's a good answer. Good. Well, thank you very much, Joseph. That was super good. Very nice project. Like if people, because this is an open source project, people can go and then like look at the stuff, use it however they like. How can people help you out on that?
So everything is at puffer.ai. If you want to get involved with the project, first of all, just start the GitHub, feed the puffer a star. It helps more than you'd expect. I think we're just about to hit 4K on the project, which is pretty awesome. Um, all the dev is on Discord. Just the link is on the website, but also just discord.gg/puffer. We just hit 2,500 people in there. Tons of really helpful folks will help you get started. There are also formal materials on the website for how to get into Sims. Really, it's like first year undergrad level C. If you've seen any low level dev of any type, like I promise you, you can actually get into this stuff. And I have more detailed guides on X. You can follow me there as well. And that's also, well, here, X, Twitch, notifications for the streams because I stream a lot of dev.
Fantastic. So thank you very much for coming, and we'll let you get back to actually do RL stuff now.
Thank you.